Hey, what's up? It is Tuesday, September 5th. Hopefully the volume or the sound is a little bit better. I actually got a microphone this time. So hopefully the sound, and no, this is not the microphone I'm using. I have a black one just like. Anyway, long story short, hey, the agenda's right down there. Make sure that you guys get that written in there. There's not much in the agenda. Only thing you're going to need today, hey, something to write with, scientific notebook, growth mindset. Be ready to learn. Let's go. Oh, you should definitely pause it. Yeah. Okay, so today we'll have tutoring after school from not Tuesday, from 3 to 4. So Tuesdays and Thursdays, today is Tuesday. So welcome back after a 3-day weekend. Get your minds right. Okay, cool. We'll move on to the next thing. This is extra credit for the progress reports. Unfortunately, Mr. Farr did not send out a parent square as I intended to. I got to figure out how to schedule it. That way it'll be easier for me. But anyway, I'll send out a parent square today and Wednesday, right? That is the last day that I will accept it for extra credit. After that, I will not accept it for extra credit any longer. All right, cool. We are through that. Now, let's talk about this for a moment. Now, we talked about this the other day. I just want to review it. So, these things, again, if you look in here, they are called spring scales because they are scales that find weight that use a spring to do so. And as you can see, these three are different. This one right here goes up to 30 newtons. This one goes up to 10, and this one goes up to 5. Primarily in the lab, you will be using this one. Sometimes you will use this one, but for today's lab, you'll be using this one. So I want to concentrate mainly on that, and I will review to this one, okay? So just remember that you got to count each line, and this goes from 0 to 1, and we are in Newton. So from 0 to 1. So you got to count each line, see how many there are, and then you kind of want to divide up that that section from 0 to 1 into however many lines there are. So if we just count through, we'll end up getting 9 in between, and then the 1 is the 10th one, right? And so what we'll do is divide it up by 10. So then this will be 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, and so on and so forth till you get to 0.9, and then this would be 1.0, and that's kind of how you're going to make that work. Over here, since there's much fewer lines, you're going to be like this. Oh, I got it 0 to 1 again, but I don't have 4 lines. So if I go 0.2, 0.4, 0.6, 0.8, and then 1.0. Cool. Now over here, you go from 0 to 5. That's a different scale. So make sure you guys are reading it appropriately. So this would be 0. This would be 1, 2, 3, 4, 5 newtons, okay? So all of them read slightly differently. We have all kinds of different graduated cylinders, beakers, Erlenmeyer flasks, all kinds of things that are on different sizes. So because of those difference in sizes, the way that they read as far as the numbers numerically are going to be a little bit different, okay? It's not a big deal. You just got to figure it out and make sure you look at the instrument before you use it. All right, cool. This is what we call step 0. Even though I'm assuming if you're watching this video, you're not in the class, but that's totally okay. I want you to know. So step 0 means the step that we were on before you entered the classroom. So Mr. Farr is on step 0. You guys be on step 1. I be on step 0. So once the class begins, like once we start the lab, this is the way that it should look. And then once we end the lab, you guys have to return it to 0 in order, right? So you need to return to 0 so that the next set of students will be ready. Main reason is this. You should clean up after yourselves. That's just one, being responsible, okay? But number 2, there's one Mr. Farr and there's a lot of y'all. And there's no way that Mr. Farr can reset the whole lab in a couple of minutes before we get to it. So that's why, these are reasons why I'm having you guys return it back to 0, okay? Cool. Let's move it forward. So we looked a little bit at this on, I don't know what day was that, Thursday, I think. So let's just take the time to read through parts 1 and part 2. Don't worry about the questions just yet, but read through parts 1 and part 2. And if you want to read through the questions, you totally can, but at least read through parts 1 and part 2, and then pause it to do that, and then come back into the teaching. Okay, so step 1 right there says, observe the teacher applying a force to the bathroom scale. What is the weight in pounds registered on the scale? So we're going to go ahead and try that. So just like all the scales I showed you, you do have to press this down first. Once it's zeroed there, then now you can use the scale. That's how every scale will work that you will use in the side of this class. I got to move it over just a little bit so it's like even on the table here. Okay, cool. So let's go ahead and press it down and see if we can come up with a number. I'm thinking about 60. Let's go with like about 64. That looks like about the most that I was able to press that thing down. So we're going to go ahead and in number 1, you should go ahead and write 64 pounds. I'm going to pause it because I got to start using the board. So I'm going to pause it again. 64 pounds, that's what you should write in for number 1. All right, so we got the 64 pounds, and then the next thing that we need to do is it says, convert the amount of weight from pounds to the amount of force in newtons. So remember that 1 pound is equal to 4.45 newtons, right? So just remember that. So let's go ahead and see if I can make myself big right there. Okay, so one thing I definitely need you guys to like understand and get. Let me find my pen right there. Okay, I'm ready. So we said 64 pounds. So regardless, let's just slow down. All right, 64 pounds. Cool. All right, so 64 pounds is equal to 64 pounds over 1. If you do not believe me, pull out your calculator right there on the screen. You can pause this, get your calculator right there. And 64 divided by 1, what does that equal? It's going to equal 64 pounds. So then, also, I do want to put this out. 64 pounds, 0.0 is also, these are all what we would call, these are equivalent, or they are equal to one another. Please write this on the top of the page in your notebook there, okay? So pause the screen, get this written in the top of your notebook right there. So I think you guys have room, like right up here, so just write that right in this section. You're going to end up writing it in your journal as well, okay? I just want you guys to get this because sometimes we will need to convert this number into a fraction. Sometimes we will need to convert it into a decimal, just depending on what we're doing or what kind of formula we're using or anything like that. So we are going to be using the conversion factor that 1 pound, right, that 1 pound is equal to 4.45 newtons, okay? So since we have 64 pounds, that is where we're going to start, 64 pounds. So that's what we measured, 64 pounds, okay? Now, to use a conversion factor, we have to multiply. Okay, here, let me just make sure it's good. There we go. You have to multiply. So we're going to multiply times the conversion factor. Now, whatever unit is the unit you are trying to convert into, that is exactly, and let me do this. I think it's like, the glare might be better if we, actually, is it okay if we, nope. Okay, so the glare is a little bit better if we do that. So 64 pounds, and then you got to multiply by the conversion factor, and then whatever unit you want to convert to, and in this case we're converting 2 newtons, you want that to be on top. And you'll see why it becomes important right after this step. So 4.45 newtons, okay? And on the bottom is the rest of this conversion factor, which is the 1 pounds. And I'm using this fancy one, and the reason I'm using that is because I don't want any confusion between this L and the 1, okay? So now, over here, we are going to convert this into a fraction because we need it to be a fraction. And we already know that 64 pounds is equal to 64 pounds over 1. So we can just use that one right there. Totally cool. Now we're set up to run through the problem. Now what we need to do is we need to actually cancel any units that we have on the top and the bottom. So we do have pounds right here, and then we also have pounds right there. Okay, so we can cancel those out. Now it's going to be 1 times 1 on the bottom, which we know that to be 1, okay? And there's no units down here because we canceled the pounds out, so it's just the 1. Now we're going to have to do the 64, which I'm going to see if I can pull that up on my calculator here. See if I can get my, handy dandy calculator. Boom, right here. Oh, and it's behind, so I'm going to have to make you guys a little bit smaller. Yep, so here it is right here. So then I'm going to be like 64 times 4.45. Is this the answer? So hold on. Before I press equals, make sure you put this into your calculator, okay? It's the 64 pounds times the 4.45 newtons on the top. Did you get the same answer as me? 284.8. So I'm going to go ahead and write that in right here. 284.8 newtons. Because that's the unit that I have up there. Here, and I just want to show that to you guys. 284.8 newtons, because I still have that unit right here. So I have to carry that over because it multiplied through the problem, okay? Now, if you're like, I don't know if that's what that's equal to, I'm like, do the last part of the math. So we'll go to 284.8, and we can just divide that by 1, and now you have 284.8 newtons, okay? Boom. So that last part of that math makes it equal to it, okay? So understand that. Totally cool. Hopefully we are good there, okay? Now what I want you to do is move on to number 3 and go ahead and do that one yourself. So pause the screen, do this one yourself, and then press play when you're ready to watch me walk through it. Don't just watch me walk through it. Try to figure it out. That's where the strength is built. So you got to try, even if you're not unsure. Once you get to an answer, then unpause the video and let's see if you got it right. And guess what? Either you got it right or you'll learn. Okay? Cool. So pause the video. All right. So here we are right here on number 3. Imagine a small child is stepping on the scale, resulting in a weight reading at 35 pounds. How many newtons does the child weigh? So we want to go from 35 pounds into newtons. Okay? So let's go ahead and check that out. So here we are. 35 pounds. I put this up just so that maybe we might be able to use that throughout this thing. So the first things first is 35 pounds. Okay? Now, because I understand that this is equal to that, I am going to go ahead and start with that because I know I'm using a conversion factor and I need to already have it in a fraction type format, okay, in order to use the conversion factor. All right. So now, again, I want to go from pounds to newtons. So newtons is on top because of the fact that I want to convert into newtons, okay? So my other units, they can cancel out. And again, on the bottom is going to be the other part of this conversion factor, which is the 1 pounds, okay? So here we are again, very similar problem. So again, we're going to cancel the pounds here and there. Totally good. And now we're just going to go 1, and I guess I should have put my fancy 1 there. 1 times 1, which is equal to 1 on the bottom, okay? And then we need to do the 35 times 4.45, and let's see what that's going to equal to. So 35, sorry, I think I said 45. So 35 times 4.45. So you guys see that? So let's see, did you guys get the same answer that I got? I got 155.75 newtons, and make sure you have your units over 1. And since I've been dividing by 1 now, and I understand that these are equivalent to each other, I can totally put 155.75 newtons. And then that's also saying this is equivalent to if it has a decimal as well. So even having the decimal, these are still equivalent, right? These are still equivalent, like regardless. So this over 1, if I do the math and just divide it by 1, I end up getting 155.75. And I'll show you guys that on the calculator in case you're like, I don't believe it, Mr. Farr. I do not believe it. Divide it by 1, and you get yourself 155.75. So again, you come to the same answer. Okay, so this is what I'm going to do because I need to actually move. So I am going to make this part 1 of the video. So this is the lesson. And then I'm going to make another video that is just going to be the lab because that's going to take a little bit too. So I'm going to cut this video right here and say this is just the lesson. And then I'll do a part 2. And then that is going to be the lab. Okay. All right. Cool. Then I'm out. I'll see you in the lab.